doing this question, but it's worth, I think, drawing a tree diagram to just get your head around what's happening. So you're throwing a dice. The probability of scoring a 6 is a sixth. You know that. She throws, or he throws, 4 fair dice. So if you use a tree diagram, with his first throw, he could get a 6, or I'm going to write N6 for not a 6. And the probability of getting a 6 is a sixth. The probability of not getting a 6 is 5/6. He then throws another dice, and he could get a 6 and a non-6 and a 6 and a non-6. Okay, these is always a 6. These are always going to be a 5/6, because every time he throws the dice, the probability of him getting a 6 stays as a sixth. Okay, so 6 and not 6 and 6 and not 6 and 6 and not 6 and 6 and not 6. You get the idea. And then, so that's 3, and then he's going to do that again. So he's going to actually throw 4 times. So 6, not 6. Oops, 6 and not 6 and 6 and not 6. You get the idea. 6, not 6, 6 and not 6 and 6 and not 6, and so on. Now, as you can see, it says the probability that it scores 6 with at least one of them. Now, if you look at which branches are going to give you that, basically everything from the first branch onwards, so this one and 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 this one, everything where the first one is a 6, he's obviously going to be getting at least one 6. He could get a not 6 and then followed by a 6, so all of these next branches are going to be okay. The probability that he scores 6 with at least one of the 4 dice, well, the only way that he's not going to get at least one 6 is if he gets a non-6, so this route down here, a non-6, a non-6, a non-6 and a non-6. Now the probability of that happening, so the probability of him getting, if you like, 4 non-6s, well, to find that, you literally multiply along these branches, so it's going to be 5/6 times 5/6 times 5/6 times 5/6. Okay, now if you work that out, it comes out as 625 1,296ths. Now that's the probability that he never scores a 6 at all. So the probability that he does actually get at least one 6, now that's going to be all of the other probabilities added up. Well, we know that all of the probabilities in total must add up to 1. So the probability of at least one 6 is going to be 1 take away the probability of getting no 6s, which is what we've got here. So it's 1 minus 625 1,296ths, which is 671 over 1,296.